Hey guys, it's Miss Wiesner, and I'm going to do this video lesson for you on the laws of exponents. There's about 6 to 9 of them. We're going to start with a couple of laws or rules, I guess, that you already know, and then I'm going to teach you 2 more you may or may not know. And then we're going to split it up in little chunks so we don't have to try to do all of them at one time. Okay, okay, this is the standard. This is actually the 7th grade standard. We're doing the 8th grade standard, but there's only a little difference. It's we're still going to do the laws of exponents, but instead of having whole number exponents, we will, in 8th grade, you're going to have to deal with negative exponents. I don't know what's going on, but I guess seeing on the flip side will happen a little bit later. I can't get this screen to go away before the next slide, so stay with me. Okay, this is an overview or reminder of the parts of an exponent or a power. This is 5 to the 3rd power, and remember the little 3 is the exponent, and then the larger number is the base, and that's going to be important when we do it later. And the whole entire thing is called the power. And the 3 just tells you how many times to multiply the 5 times itself. Okay, so what you are supposed to already know, I guess, is the zero product property. This says that any number to the power of 0 is 1. So 4 to the 0 power is 1, 3 to the 0 power is 1, x to the 0 power is 1, negative 3 to the 0 power is 1. And sorry, you can see I've not taken care of my iPad, so it has scratches and everything, so it's kind of hard to write on. But anyway, nevertheless, this is the reason why. If you take the powers of 10, I'm doing really good here. If you take the powers of 10, like 10 to the 3rd, that's 10 times 10 times 10. 10 squared, there's 2 tens. 10 to the 1st, there's 1 10. 10 to the 0, there's just the number 1. So as the exponents go down, so do the number of zeros. Till we're left with 1 and no zeros at all. 10 to the 0 power. So we can take that pattern, since we are in the base 10 number system. This could be a reason. We'll learn another reason later on, but this is based on the power of 10, and it's a pattern that shows that anything to the 1st power is that number, anything to the 0 power is 1. And we just talked about that. Power of 1, any number raised to the power of 1 is that number, and you can see why in the power of 10 pattern that we just talked about. So we don't put the 1 there. You're supposed to just already know that it's there. So it kind of looks weird to have, instead of just writing the variable x, if you wrote x to the 1st power, it looks kind of weird. So don't do that. Okay, so we're going to be dealing with negative numbers, and so it's going to be all about the parentheses. So when you're working with bases that are negative, you have to pay attention to whether the negative is inside parentheses or whether it's on the outside of the parentheses. That is going to really determine or cause your answer to be right or cause it to be wrong just by a little negative number. And it's a scary thing to think about, those little negative signs in the parentheses. So don't be too scared. It's not that hard. Laughter, ha. Okay, so you have negative 3 to the 3rd power and this negative sign on the outside. That means that this 3 only the exponent 3 only goes with this base 3. The negative is not being raised to a power. So we kind of ignore it for a few minutes, and we do 3 times 3 times 3, and we get 27. Now we take care of the negative, okay? Because that negative wasn't being raised to the third power. Just 3 was. Now here, the negative's inside the parentheses. So this entire thing right here, this entire negative 3 is being raised to the third power. So it's negative 3 times negative 3 times negative 3. And a negative times a negative times a negative is a negative. Negative 27. Here again is just a couple more examples. This is exponent on the outside. So the 3 is being raised to the fourth power. So you multiply 3 times itself 4 times, and then bring that negative over and put it in your answer. But on this one, the negative 3 is inside the parentheses, so this entire thing is being raised to the fourth power. So it's negative 3 times negative 3 times negative 3 times negative 3. If you broke this down, that's positive 9, and this is positive 9, and 9 times 9 is 81. That's why this answer is positive. Okay, so this is the product rule, or the product of powers. It just says when multiplying powers with the same base, write down the base and you add your exponents. So the example I have here is a to the fifth power times a to the second power, right here. So what you do is write down the base, which is a, and you add your exponents. 5 plus 2 is 7, so a to the seventh power. Here's the proof, but a to the fifth times a squared equals a to the seventh. But just in case you still have that gnawing question. Okay, here's how it is. You have a to the fifth power times a to the third power. So what I did was I just wrote out a to the fifth power 5 times like I did in this on the other problem, and then a to the third power, which is 3 of them, and then you just add them up. How many a's do I have? Pretend like this isn't even here. This would be a to the 8th power. So that's how that works. It's a pretty simple concept, but sometimes it can be a little confusing if you're not careful. Here are some examples that I did, and then I'm going to give you a chance to work on some, so I hope you have paper ready. If not, get it ready. So 5 squared times 5. Notice that this 5 doesn't have an exponent, so I know that that exponent is 1. So I just added the exponents together. I wrote the base down, 5, added the exponents, and got 3. 5 to the third power. Now, I didn't give any directions, so I'm just going to leave it as an exponent. But there will be times where you might have to work it out, but we'll talk about that later. This is c to the third power times c to the fifth power. So all you have, since I have the same base, all I have to do is just add my exponents together. And 3 plus 5 is 8, so c to the 8th power is the answer. Now this one, we're going to use one of our properties, or actually a combination of our properties. We're going to pull this 4 and this negative 3 away from the variables because we want to separate those so we can keep the exponents together. Just makes it a lot easier. You don't always have to do that. I mean, this might be a step that you would do in your head, but anyway, I'm just writing it all out. So negative 3 times 4 is negative 12. And then I have x squared times x to the fifth. Well, then you do x to the 2 plus 5, or x to the 7th. So the entire answer is negative 12x to the 7th. Okay, we're going to pause this, and I want you to do these, and we'll work them out after you get your answers done. All right, work these out. Okay, so for the first one, you have 9 to the third power times 9 squared. So that's going to equal 9. See, I told you the scratches. 9 to the 3 plus 2, oh my word, equals 9 to the 5th power. And if you laugh at me, then you have to figure out what 9 to the 5th power is without using a calculator. So b to the 6th power times b to the 3rd. So that's the same thing as b to the 6th plus 3, which is b to the 9th power. Alright, and this last one, change colors again. So let's do negative 2 times negative 8. And that is positive 16. And then this m has a 1 there. So you can write it in if you need to. So m to the 1st power times m to the 5th power is m to the 1 plus 5, which is 6th power. So that's the answer. I hope you did well on those. If not, maybe we'll do some more examples later. Okay, so this is the quotient rule, or quotient of powers. It's just saying that when you divide powers with the same base, you subtract the exponents. So multiply, you add, divide, you subtract. So it kind of goes along there. So here's an example that I have. X, stop it. Where's my little pointy thing? X to the 7th power, there it is. X to the 7th power over x to the 3rd. Okay, so this is x to the 7th minus x to the 3rd. So you have to subtract your exponents. You get x to the 4th. I think my husband's spying on me. Anyway, so the answer is x to the 4th. Because, first of all, there's a new word here, vinculum. What a vinculum is just a bar that separates one quantity from another. So the bar that we use in math most often that does that is the fraction bar. But especially in exponents, we're going to be separating quantities that reside up on top of the bar and below it. So this is the vinculum right here. And another place you might see a vinculum is in division, the old division bracket. But anyway, just something that you don't need to know. And if you're ever in a trivia contest and that word comes up and you win, you can think about this math class. So here's how you can prove it. So you would go, I'm going to use green. You would do x 7 times. So I'm going to write down 7 times. 1, 2, 3, 4, 5, 6, 7. And then on the bottom I have 3 x's, or x to the 3rd power. Then all you do is for every one x, you can mark out another one. So I have one here, mark it out here. Have one here, mark it out here. So what do I have left? When all that's said and done, I have x times x times x times x, which is x to the 4th power. Done and done. All right, here's some that I did. 4 to the 8th power over 4 squared, or 4 to the 2nd. So I told you my iPad messes up. So 8 minus 2, that's ugly. So 8 minus 2 is 6. That's 4 to the 6th power. Now, this example here, n to the 9th power over n to the 4th. If you subtract your exponents, you get 5. So it's n to the 5th power. Now this one's kind of jumbled up, and you're not going to have to do very many of these, but what you would do is take these in sections. So I would do 2 to the 5th over 2 squared, and I got 2 to the 3rd. Then I did 3 to the 5th over 3 to the 4th, and I got just 3. Or you could put 3 to the 1st power, but that doesn't look right. And then 5 squared over 5, which is the same thing as 5 to the 1st. So I'm not going to put anything there. You might see, well, gosh, that's just 3 times 5. Well, so that's 15, and 2 to the 3rd power is 8. So you could be asked to give answers. I'll let you know if you are, but That's not my idea of fun to do that. Alright, why don't you hit pause and try these 3 problems and then we'll finish up. See you in a minute. Okay, so you had 5 to the 7th power over 5 to the 4th. So that's going to be 5 to the 7 minus 4. I don't know why I keep saying it like that. But anyway, it's 5 to the 3rd. Oh my word. 5 to the 3rd power right there. Box it up. Alright, let's look at the next one. You have x to the 10th power over x to the 3rd. So write down to 10, subtract your exponents, and you get 7. Now, you're not going to have to write this step out all the time. I mean, you do that in your head. But I'm just showing you exactly what you're going to be doing, so I'm showing all steps. So on this one, just like we did on the multiplication one, or the last one we did, I'm going to separate the 12 over the 2. I'm going to keep that separate. So 12 divided by 2 is 6. Alright, then I'm going to have the w to the 5th over w, remember that's a 1 right there. So it's w to the 5th power minus 1. So it's 6w to the 4th. Okay, and then box it up and be done. Alright. I don't know what my problem is, but you're probably thinking, what in the world is she doing? And to be honest with you, I don't know. That's supposed to be an X. Duh. Miss Wiesner, come on, get with the program. That's supposed to be an X. I can't tell you how many times I've looked at this and it looked right to me. So actually that answer is X to the 7th power. I don't know where I got that 10 from. Man, oh man. I guess I'm just tired. Alright, well, this was the exponents, product rule, and quotient rule. And you'll have some practice problems to do. And then come back and we'll do another video and I'll go over those answers with you. So check your Google Classroom and peace out.